Welcome to Purgatory. In today's lesson, we will go over AP Unit's topic on representation of reactions, absolute entropy, and entropy change. So what is entropy? Well, entropy is the measure of disorder within a system, or to be more specific, a measure of how spread out energy is. Obviously, energy is the capacity to supply heat or do work to a system, so naturally it would be connected to thermodynamics, the study of the relations between heat, work, temperature, and energy. So, more about entropy. As you can see on the board, the change in entropy can be found through this formula: delta S equals S of the product minus S of the reactant. Of course, this formula is useless without the quantity, so we're going to ignore it. This little graph thing we can also ignore till later. Moving on, you might be wondering as to what the hell this box is. I really don't know, except I do. It's a particulate diagram, maybe. These dummies represent the atoms of a water molecule. At first, they're slow because it's solid. As I increase the temperature, their speed increases as well as their separation. Wow, look at this spatial configuration. The opposite happens when the temperature is lowered. Isn't this so fun? I don't even know what I'm doing now. Bear with me. Wow. Remember this amazing diagram? Obviously, you can imagine the particulate model as water undergoing phase change, that being melting, boiling, condensation, etc. Energy enters the system from the surrounding, breaking the bonds, thus meaning it's endothermic. Vice versa for the exothermic. As mentioned previously, entropy is linked with enthalpy. Okay? Wow, look at this board and that house behind it. Let's walk inside. Well, would you look at that? Methane and his two kids, Oxygen, are living peacefully in this little limestone shack. So let's destroy it. Combustion reactions are what you would think of whenever turning on the stove. Methane is a common gas found not only in the atmosphere, but also in appliances. Of course, behind me is not exactly a stove, but something explosive works nonetheless. Heat energy serves as a driving force for the reaction to head towards completion, resulting in a fiery heat ball. And as according to the first law of thermodynamics, the energy is transferred outwards, thus making it exothermic. Now our good friend George W. Bush will deliver a payload of his balls onto this poor family's home. Stupendous. Another particulate model, if you will. Before, it was a fairly stable solid, and now it's everywhere. You can just imagine the limestone as a spectator ion, I suppose. So, in the end, what are you supposed to take away from this sorry excuse of a game? Well, as you can see, it has become a cesspit. It's a complete mess, much like my week has been. So obviously, I'm going to correlate it to the second law of thermodynamics. Entropy is always increasing in the universe. Okay, bye. Good luck with final week.